Okay, it's live now. Good. So let's start with the first class today is the assignment operators. Okay. So how many people are there today here? Only 7 people? Wow.
They're probably going to log in at 6.
Yeah, I just posted on Slack that we're gonna start. Okay. 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 Can someone just reply to the message that I said on email? Just reply to all and say, guys, we started already. Can someone do that for me? Or maybe I can do it.
Yeah, I will do it. No problem.
Okay.
You do it?
Yeah.
Okay, please.
Yeah.
I think I should do it, Anand, because probably they see your email and they don't know your email.
Okay.
Probably they ignore that. But if I do it with mine,
Okay.
right? So let me
All
do.
right.
Just give me 1 second. Let me just resend the one that I said today. One moment, please. Okay. Okay, just give me 1 second, guys. Okay. Good. Done. Good. All right, so we're going to talk about the first one. The first one, like I said, is going to be assignment operators. I'm going to create a class, right? And I'm going to call it assignment operators. Okay. Let me share my screen. Let me share my screen. All right. Let me share my screen. I'm not sharing my screen. I'm going to share it now. So now I just created this guy here, okay? The assignment operators class. Now I'm going to bring our friend, the main method. Okay, this is the one that allows us to run the program. Okay, good. So if I do this, right? What do you think about this, guys? Do you think it will compile? Do you think it will compile?
No, because it needs to be double.
Or
No,
red?
it is double.
Or a float? Okay.
It's a, yeah.
So we're expecting an integer. So we are assigning the wrong value. So we will have to make this a double to be able to, make it work. Or probably if we just do this, right? And we add an F here, it works. Okay? So, but not with an int. Okay? Not with an int. That won't work. Okay? So be careful in the exam. If you see that, that's, okay, you will tell them, wrong person, wrong time. You're dealing with the wrong person. I'm not going to buy this. This is wrong. Okay? So this does not compile. Okay? Now, if we do this, how about this? What do we get here?
This is wrong.
Okay? We provided an int and it's required a short. Okay? So this will give you a compilation error too. Okay? So this does not compile either. Okay? Right? Good. How about this one? Does this work?
It's not an integer, so it won't compile.
It won't compile because we are expecting a float. not a float, a long.
A long.
If we change here to long, then it works. But we are providing a long to an integer. So run. This doesn't compile either. Okay? All right? Very important. Okay? How about this one? But this works?
No, that won't compile.
No, because we're expecting what?
Floats.
Long data type.
Or
We're expecting either a double or
double. So,
so we're expecting a long and we're providing a double,
oh, right, right.
right? So this does not compile either. Okay? So 4 examples of something that does not compile. Now, how can we solve that? The first one, how can we solve that? We have 1.0. How can we solve that? So there's something called casting, right? So we can do this, problem solve. Okay? So what this does is to turn whatever number I put here into an integer. Okay? So we're just casting this. Casting, remember casting is convert. We're converting this, which is a double, into an integer. Okay? That's one way to solve it. Okay? Now, guys, this is another one. Ln x, not that x, maybe p, maybe L. Do you think it will work?
To put the L.
Yeah, does it need L in the end?
It needs an L here, right? So otherwise it doesn't work. So let's just select it here and say this does not compile with the L. Okay, that's not compiled. So we fixed the first one, right? Now the second one. How can we fix this one? Right? Let me copy this. Right? How can we fix this? Just take a look at the first one. How can we fix the second one?
The same way, short in brackets.
Right. So we just this is not bracket. This is parentheses.
Yes, thank you.
Yeah, brackets is this, right? Square brackets. Okay. So we're just casting this to a short, and then it will accept this. Okay. There has to be a match between what I'm assigning and what I'm expecting. Okay. So that's why we're putting this short here. How can we just do this one? How can we fix this?
Let's remove the L.
You can remove the L or simply do this. And it's fixed. Okay? If just in case you don't want to remove the number or just change the number or do whatever, okay, you can put it this way, or you can simply remove the L and problem solved. Okay? But remember, if you remove the L, you're passing an integer, right? We're trying to pass a long. So we have to change the long to an integer. Not by removing L, but just casting and putting int in front of L. And now this one, how can we change this one? This one?
Change the data type to double.
Just add long in the beginning.
Or okay.
Okay, we can do that one.
Professor, would you please add a comment that it's casting, called casting on top or someplace?
Say that again?
Would you please add a comment that it's called casting? Thank you so much.
Perfect. Casting to an integer. Casting to a short. Casting to an integer. and casting to a long. And when I say casting, I'm saying converting. Okay? So this is the same as converting. Okay? Good. So now we can print each one. So we can say sys out, and we say x equals, and then x. Guys, we have to fix this one too. And that's pretty easy. Okay? That's pretty easy. So we don't even have to cast. We just put L here and solve the problem. Okay? We can put a long here, but this is another way to solve it. But just adding the L at the end. Okay? So now we can just print all of them. Okay? And change just the variable. So we have here Y, and then we change for Y. We have here Z, and let's put here Z. We have here T, and just remove this T. And then you move this L, and then you put L. Okay? Now we just run this, we run it. We can see that we get all the information that we need up here. Remember that my output is not being here anymore. It's here. Okay, guys? For you to see it better. But I can put here two sys out here, so you can see it a little, further down, Let me run it again. And then you can see here more like in the middle of the screen, like this. Okay? Beautiful. Okay, yesterday we saw something about the byte. Guys, a byte goes from one number to one number.
Minus 127, minus 127 to 128.
No, all the way around.
Okay.
We're close. Minus 128.
Minus one.
Minus 128 to 127.
Mm-hmm.
Okay. So let's have a byte here, right? And say my byte. Okay. And then we say 127, right? And say here byte, my second byte, and we'd say minus 128. Okay. Let me just format this. Okay, good. Now, if I print this, guys, this out, I can say my byte equals, and then my byte. And I can say this out, my second byte equals my second byte. Okay, so now I just run it, and we get the same 28. Right? So because we are in the limits, right? We are in the limits. But what if I do this? What do you think we're gonna get?
You won't compile, you gotta cast it to byte.
Because I provided an integer, right?
Right.
Right? But what if I do this? You see?
Right.
Right? So I get 125, right? But remember that on Tuesday, we had a calculation, 125 plus 25, remember? We added 2 bytes. Remember that? Let's do it again. So I do here, adjust my byte 1, and then I have 25. Okay, that's fine because it is within the range, minus 28, 27, right? Now, if I do just the sum of these guys, and I said sum equals, sorry, byte sum equals my byte plus my byte one, and I get this problem here because we have to cast this to a byte. So we say here byte, sorry, and then I cast it to a byte, right? So now if I print this guy, sum, and I just run it, I get 106. Remember that the numbers has to go between minus 28, 128 until 127. Okay, that's what happens when the number is greater than 127 or greater than 128. Or actually not greater, smaller than 128. Yeah, because in the negative realm, the negative number realm, the bigger the number, the smaller it is. Okay. So you guys understanding here? That 146, that 140, right? 140 is practically
Yeah, but Professor, I got a question.
Go ahead.
Isn't the sum of those, shouldn't that be 150 and shouldn't it still throw an error?
140. What do you mean?
No, 125. My byte is 125 and my byte one is 20.
It's not 150 because a byte goes from, this is a byte, okay? A byte goes from minus 28 positive 127. Okay, and the number that you're getting here is 150. That is not in this range. Okay,
Right.
I think were you here on Thursday? On Tuesday, I'm sorry.
Yeah, it was.
I think I demonstrated this. If you have 128, if you're, see here, see this, the sum here. Let's see what we get. We get 127 because that's the last one. But if I do 3, we're gonna get minus 128. It's right here. It's just when it goes over 127, it goes back to 128.
Oh, okay.
And then if it is 4, that is 129, then it goes back to minus 127. And it will be in that range all the time.
Okay, yeah.
Okay? If I change this to 4, it will give me 127.
Okay, I see.
You see? And it will be doing that all the time. If I put this 5, it will give me 126. Yeah. And then if I just put 40, right, it will give me 91.
All right, I see that.
Okay. What if I put 130? Then we have a problem. It's too much. It just go out of the range.
Right.
Okay. So it's gonna be there between anywhere between minus 128 to 127. That's why when we assign 129, we get an error. Because the byte goes from minus 128 to 127. If I do 122, then it works. If I do minus 125, it works.
Yeah.
But if I do minus 129, we get an error.
Exactly. Okay. Oh, I see.
That's the most that a byte can store. Okay. Right?
All right, thanks.
Okay. So that's what calling in Java overflow and underflow. Overflow is when it goes beyond, and underflow is when it's between the range. Okay. Now, the next that we want to see is, let me see here. we can do this, right? And practically, what we do here is just what? What is this? Can someone tell me what this represents? Can someone tell me what this represents?
Use, then increase.
Correct. But this is the same as this. Is exactly the same. Remember that when you increment, you're incrementing by 1, right?
Right.
It's the same as
Yep.
this. Right? So if byte is 1, then when this operation is done, it's going to be 2. Okay? Because this is an increment by 1. Okay? So guys, when you see this, my byte in a program, what you're actually doing is just this. Actually this. Right? Same thing. But remove this 2 here because we don't have anything there. Okay? That's basically what we're doing. Okay? Right? So we saw a lot of exercises about this on Tuesday. Okay? And we're going to see some more today. Right? So now if I print my byte, and here instead of my byte, I'm going to save my second byte. All right? And now I'm going to print my second byte. Let's see what happens. You see, before my byte was 125. Now it's 126. Right? And then before it was 127, 128. Right? But what we did was, you know, one month, of course, is 127. Okay? Because that's going to be 128, 129. Okay? So it becomes 127. Okay? So let's say that you have here 125 and then this. Let's see what happens. You get 128, right? And then it becomes 124. But this one is the one that we're seeing here that becomes 128, right? But what if we do 4? Then it becomes 127, all right? And that's what is happening with this, the way it was before. Is we're getting, guys, when you use this one, what's happening? This is becoming what? Let me print it again. That's becoming what? Okay, one moment. It's becoming what? 126, right? And then when you do this, what is this one becoming to? My second byte is becoming what?
127.
127, right? Right here. So it's kind of confusing at first sight, but once you get it, you know, hold of it, you know, understand it better, then it becomes easy to understand. Because guys, in this exam, you have to think like a computer. Okay? Because all of these calculations, all of this, you have to think it before you answer the question. So that's why, once again, I highly recommend schedule your exam at a testing at the testing center. Okay. So we have this guy here, short A equals 10. That's fine. Okay. Short B equals 20. Short C A multiplied by 20. Okay. What happened here?
Say it's
What's happening
200.
here?
See, it's going to be 200.
Yeah, this is returning an integer. So you have to cast it to a short. And of course, you have to add this one as well. Guys, when you are casting only one element, you can put this like this, right? And that works. But when you are casting an operation, then you have to cast the whole thing by doing this. Okay? Very important. Now, if you do sys out, and then we say C equals, and then C. And of course, we're going to get multiplication here. And by the way, this is not 20, this is B. Okay? And then if we just multiply this, just run it, we get 200. Okay? C equals 200. Okay. Are you guys understanding this kind of assignment and casting for operations or casting for only one element like this one here, right?
Yes.
When you do an operation, you have to cast the entire thing, okay, like this one. And very important, see what you are expecting. You're expecting a short, then cast everything to a short, okay?
Mm-hmm.
You're expecting a byte, you cast everything to a byte, because there cannot be a mismatch, a type mismatch. There has to be a match here between what you are assigning and what is being expected. Okay? Any questions? Yes, no, maybe.
Yes, I have a question. So for the increment and the decrement, so I guess it doesn't matter if it's before or after the variable.
Well,
It'll apply the same way.
Well, Maria has the answer for that. Maria, do you think it matters?
I'm sorry, I was not paying attention. Say that again.
Maria, he's asking if, does it matter if the plus plus or minus minus or minus minus plus plus whatever is before or after the variable? Does it matter?
Oh yeah,
Yes.
it does matter.
Yes.
Yeah, it does matter.
Were you here? Who was the one that asked the question?
It was me. I was just playing around with it and I had the question.
Yeah, were you here on Tuesday?
Yeah.
Okay, maybe if you can just take a look at the video, watch the video. It does matter. It does matter. Remember.
It does matter a lot.
Remember, when you have the plus plus, the increment after, it means that first you use and then increment. And when you have before, first you decrement and then use. This is very important when you have operations like this one.
Mm-hmm.
Super important. Okay, super important. That matters a lot. I can tell you that it matters a lot. All right, but sometimes when you're doing a for loop, you don't care much about that because you will get almost the same results. But when it comes to an operation like this one, it does matter. It does matter. Okay, guys, so let's have another class. If you don't have any other questions, let's have another class, and then let's call it compound assignment operators. Compound assignment operators. Okay. So we just have a simple assignment here. X equal 2, very simple. We're assigning a value. Remember, there's a big difference between 1 equal and 2 equals, okay? The first one is assignment and the second one is comparison. We compare things, okay? So 1 is for assignment, okay? Don't forget that. Let's do another assignment here. Let's say int x z equals 3, okay? So now, we can just do this. What is this? Wait. Okay. we can do this easily. Say X equals X multiplied by Z. Okay? Right? Or, and this is called simple assignment. Okay? What are we doing here? We're just getting the value of X, which is 2, multiplied by Z is 6. Now the new value of X is going to be 6. Okay? We're just reassigning a value because originally X had a value of 2. But now X is going to have a value of 2 multiplied by 3. That's going to be 6. So if we print X now, says, sorry, this is out, and we say X equals X, right? We run this, we get that X is 6. Okay, so X has a new value. Do you guys understand that? What I just did?
Yes.
It's like going to the registry or whatever. When you do your citizenship, you change your name. Similar, right? Your name is Maria, then you become a citizen, and then your new name is Carla, for example. Okay? Still accepted.
Marie.
Okay,
From
still
Marie Abdul Marie.
okay, Mary. Okay, still accepted, you know? Or when someone marries another person, typically women, they change their last name in the citizenship application, for example. That's a good time to change your name. Okay. So we are changing the value of X, which was originally 2. Okay. Reassignment. Now, another way, guys, another way which is very, very, very important to know is the short form of this simple assignment, which is this one. Pay attention. Take a look at it. So this is the same as this. Okay? And in programming, this is more common and popular than this one. Okay? This is the same as, just tell me yourself, please. Tell me. Is the same as?
X plus Z.
Correct. This is the same as what?
X minus.
Correct. And this, sorry, this is the same as?
X divided by Z.
And how about this one?
The remainder of X divided by Z.
Right, it's the same as modulus. Okay, guys? That's for you to understand. All right? So let me put this here. All right? And let me put this guy here. More beautiful. More beautiful. Okay, so that's the way it is. Okay? So another way to say it. So now if we print this, we're going to get that X is 18. Why, guys? Why is it X 18?
Because the first one multiplies X by Z, and then the second one does it again.
Okay.
There you go.
See, guys? Okay, you see there? Perfect.
Mhm.
This is a shorter form of x equals x multiplied by z. Okay, for you guys to know.
Can you extend the equation beyond the z? Can you say x times equals z plus 20?
Can you try that?
Perfect.
Doesn't matter. It's just it's gonna do this like this and
Mhm.
then plus 10.
Mhm.
Okay,
Nice.
let's do 34.
Makes it so much easier.
So it's gonna multiply 16 by 3 plus 10. Good. No? Now, guys, this does not compile. Okay? That does not compile. First, you have to declare that int, like I did here, and then you can do that. Okay? But you don't do that here. You don't work with types. You don't put the type here when you do this operation. Okay? So this does not compile. Okay? Now we can have this ln a equals 10. Okay? That's possible because 10 is a short number. It's a very small number. And remember that an integer can be promoted to a long. Okay? So this is without any explicit casting. Okay? Or cast. Okay? It's a very small number. Or this one, for example, b, which is very obvious. That's also no this. Remember that this can be a short. Okay? If I do short c equals 4, that works, right? So this could be a short. But shorts are promoted to ints. Okay? You always promote to a bigger one. Remember that promotion is changing smaller to bigger, like we saw on Tuesday. And casting is changing bigger to smaller. Okay? So that could be it. Now this, if I do this, b equals b multiplied by a, what are we going to get here? An error, right? Why? Because we are expecting an integer, right? And we have a long in the middle.
Right.
So we have to do something like this, right? To be able to fix it, correct? Like we did before. Okay? So let me put it the way it was before. So this guy does not compile because we have two different types. One is a long and one is an int, unless I cast it. Okay? This does not compile. That's not compile.
But Professor, you could have also just casted the A, right? I mean, I guess
in an operation.
Huh?
In operation? No,
Right.
that's the entire thing.
But B is already an int, though.
Sorry, where?
No, I mean, I understand what you're saying. I'm just.
You can. Yes, you can have this. Yes.
No. I mean, in the formula, B equals B times A. You could have just casted the A since the A is the one that's not.
Okay, let's do it. Let's do it the way you're saying. Okay, so B, is that what you mean? B, and A Is that what you mean?
Right. Times B.
Right?
Oh, it still doesn't take it.
Yeah. Because the problem is that a long, an int is promoted to a long. So those are two similar ones.
Right. So it does work, or no?
Yeah, it does. It does.
Oh.
It does.
But convention of a programming convention say you do the whole
Well, it depends. It depends on the situation. Sometimes it doesn't work. Sometimes only one doesn't work. Sometimes it does. Okay. This way works.
Yeah, of course, yeah. Because you
Both
take
ways.
the whole thing.
Okay. So this would be this compiles. Okay. As well as B equals int okay, A. This one is more common than this one, but still this works. All right.
Okay.
Good.
Yeah.
Now we can do this and say B multiply equals A, right? And then we can print B. So guys, what can we get here? What do we get here?
Error. It's an integer.
What do you?
You have to put int.
Huh?
You have to convert it into int.
Well, it's not giving an error.
Yeah, it's not.
So what do we get here?
Be a runtime error?
So here, something interesting happens. It casts for you.
It casts automatically. Okay.
It casts automatically. So this is the same as sorry, this one or this one. So it does the casting for you.
Wow.
Okay, that's why you don't get an error. But here, you get an error. You see? Interesting, huh? So now if we just print this, we get 40. Okay? Because it will be 4 multiplied by 10, that's 40. Okay? So just bear in mind that this compiles, but this one doesn't. You see, Java is crazy, huh? It's a crazy language, but it's not as crazy as JavaScript. If you're taking JavaScript, you're gonna, go crazy with JavaScript. It's very unpredictable. Java is more predictable than JavaScript. So C, long C, 4. That's another example. And then we can do long D, and then we can say C equals 2. How about that? Interesting, huh? So what do you think is going to be the value of D? Let's see the value of C and D. So we say this out, C equals C and D equals D. So what do you think is going to be the value of each?
I think D turns into number 2, equal to 2.
And
And
C?
C becomes 2? Let's see. That will be interesting. Yay, C is equal to, D is equal to.
Yeah, we are reassigning. We're reassigning. Here, we're assigning 2 to C. It was 4 before, right? And that value that we get from here is given to D. So C is going to be 2 and D is going to be 2. Okay. So this is basically the shorter form of C equals 2 and long D equals C. Same thing. Do you guys see it?
Yep.
We're assigning 2 a C, and then we're assigning C to 2. Okay. Guys, so it's like doing this. And then this. Of course, we have a problem here because we have the same variable 2 times, right? So we have to do this. Similar to that. Okay, so we are doing this basically, is the same thing as this. So if we do run it, we get exactly the same result, right? But let me put it the way it was before. Okay. Okay. So you guys see it? You understand it?
Yes.
Very good. It's good to know that. But only one person is answering. How about the rest of the class? Yes, no, maybe.
I did answer.
Okay. Good. Let's have another one. So now let's have ln E equals 3, ln F equals 2, and ln H equals 1. Okay. Now let's have this. Beautiful. Beautiful. E plus 3 multiplied by F equals 3, and then minus H minus equals 2. How about that? Plain cosine. Okay. So now we say, right? Now we print this is out. E equals E. E. So guys, you can analyze in the meantime while I print this. Okay. Then we have F H E I. So let's see. What is the value?
I think high is 10, F3, H1.
Should we print it?
Go
Let's
ahead.
see what you have.
Oh, hold on.
Okay, Maria, go ahead. Continue.
I is 11, H is equal to 1, and F is equal to 3. Let's see.
Okay, guys, can we print it?
Yeah.
Okay, let's do it.
Right.
E is 3, F is 3,
H is minus 1.
and H is minus 1, and I is 13. Is that what you got?
Yep.
Is that what you guys got?
I got
Okay.
that.
So let's see it. First time the f becomes 3. Okay, we see here, right? F becomes 3. Now we have, second one, we have E plus 3. Sorry. Plus 3 multiplied by 3, right? And then we have minus 1. Right?
Right.
Because this becomes minus 1. Okay? So that is the same as, H minus equals 2. Then also sage H equals minus 1, right? So that will be H equals H minus 2, right? That's this.
Right.
Okay, good. So it sets H to minus 1. Okay. Now the other one is E plus 3 multiplied by 3 plus 1. Remember that when we have minus multiplied by minus, it becomes positive. Right? That's algebra. Okay? Algebra here. So minus multiplied by minus, it becomes positive. So that would be plus 1. Now E is originally 3, right? So we have 3 divided by 3 minus 1. And that will be 13. You got it, guys?
Mm-hmm.
So 3 multiplied by 3 is 9, plus 4 is 13, plus 3 and plus 1, 13. Okay? And of course, F is going to be 3 because it's right here, giving a 3 value right off the bat here. And then E becomes, it continues to be 3. Okay? So this is much easier than what we saw on Tuesday. Okay? We don't have any incrementer here, any modulus or anything here. Okay. Any questions, guys?
No.
No questions? This is do you guys understand this, how it works?
Yes.
Are you thinking more like Java? Are you getting closer to the way the machine thinks? Getting closer? Okay, so let's see another class. Let's now see the relational operators. Okay. Relational operators. BSVM. Okay, always that. Let's have a variable. Let's call it int equals 10. Let's call it x. Another variable called y. Another integer, and let's give it a 20 value. And z, and let's give it a 10 value. Okay. So let's do something here. Something really interesting. So let's say sys out, and we're gonna say x less than y, right, equals, and we say this x equals y. What do you think it's going to return, guys? What do you think it's going to return?
Boolean.
Correct. It's going to return a Boolean. It's going to tell you if it is true or false. And right here, if we hover over that, it tells you that it's always true. Because 10 is smaller than 20. So it's always true. Okay? So we just having a relational operator here, less than, greater than, because we're establishing a relationship between the two of them. So now we're going to do greater or equal, right? Y. The other one was saying not greater or equal. This is smaller or equal, right? This is greater or equal, right? And then we're doing this right? And the other one is going to be greater than, and then greater than. Okay? Let me put two spaces here so we can see it more to the center of the output console. Okay, so now if I run this, let me run it this way. Okay, and now if I get here, I'm gonna get that this one is true, this one is false, it's true as well, this one is false, and this one is false. Because remember that 10 is smaller than y. That's why this is gonna give you true, but 10 is never greater than 20. That's why you get false here and false here. Okay, guys? So you can print values like this and it returns a Boolean because it's comparing, right? You understand it, guys? You see it?
Yep.
We have another value here, int a, and then it's going to be 10. Right? And then we're going to have a long, which is b, and then it's going to be 5L. And then we have a double C, which is going to be 7.5. Okay. Remember, double, we don't need to put D. It's optional. Okay. Now we're going to say, sysop, we're going to say A less than B equals, and then we say A less than B. Right? It's going to tell me that it's always false, right? And now we're going to have system, sysal. Well, actually, let me see, just copy this guy so I don't have to type it again. And we're going to say greater than, and then greater than. So now if I print this again, I'm going to see this sysal. Okay. If I print this again, I get false and true. Okay. So A is 10. So 10 is not smaller than B. Okay. Remember that an int can be promoted to a long. Okay. That's why this comparison is possible. Okay. Now A, it is greater than B because 10 is greater than the 5, right? And the same happens here. Okay. So another one here is that we can have sysal. We say int d equals 12. Right? And then we can see long e equals 15L. And we can say double F equals 14.5. Okay. Now let's do this. Let's compare D less than E, right? Plus space in the middle, right? And then let's do another comparison. E greater than F. Guys, what do you think it's going to return?
Okay, I will answer.
True.
True.
True. Let's see.
Yeah.
Let's see.
True. Correct.
Yes.
Okay. So when it comes to comparison, you can compare long with a double with an int with a long, things like that. They just work with the comparison. Okay. Good. So, you know, it's another way to compare here. You see the space here? You say? This is a way to separate two different results, two different outcomes, okay, by just putting a space in the middle, okay? Just if I want to print, for example, I say string, first name, Lunieski, right? String, last name, Hotel, right? Sorry. This out, F name plus NA. What do you think is going to happen? It's going to look horrible, right? Well, not that horrible, just a little bit weird, you know?
You just need a
Need that
space to put a double quote in the center plus double quote for space and then plus.
Right.
There you go.
And then it looks better.
Ah, you need to print the ñe. La ñ.
Oh yeah, yeah. I have to look for that particular
the Unicode for the ñ.
correct. Okay, so maybe if I do this concat
Mm.
and let's say NA, and then I just this out. Channel, right?
Yeah, you might need a space again.
Yeah, I will have to leave a space there somewhere.
And double quote, space, double quote, plus. There you go. That will work. Yep.
That's another way to do it, okay? With this method that the class string has, concat. It will concatenate that string with something else, okay? Maybe if we do the same here, but instead of another string, we can put here concat 57. But we get here an error because that's a string, right? Okay. So we could say here string value of, and then 57. And that should do it, okay? And then I concatenate it to things here. I said Dunieski 57, right? So that's called similar to method chaining, like having a method with another method. But we're gonna see method chaining when we get to strings. Okay, string is a super powerful class. We're gonna see string probably the class that's gonna show more in the exam than anyone else, any other class.
Professor, one question. Instead of declaring 57 as a string value, can we put it inside of double quotation? Will it work the same?
Of course.
Okay.
Like this. Works the same.
Oh, okay, perfect.
Yeah. Because
And
basically what we're doing with that string value of is just parsing that number to a string. Just changing this number to a string. That's why it
okay.
works.
Thank you.
Okay.
I need a break.
Yeah, we're gonna take a break. Yes. So guys, let's take a break and let's meet here at let's make it 7. Okay.
All right, Professor.
Not a problem. Okay, guys, it's 7 o'clock. Let's continue. Okay, so we were talking about this guy here, how to print several, how to compare different variables, different values, long, integers, doubles, and then we did some concatenation here, like some sort of operation with strings to be able to concatenate two strings, okay? So let's do the other one. Let's talk about the conditional operators. So I'm going to create another class here, and I'm going to call it conditional.
Are you sharing your screen?
I'm going to do it now. Okay. Conditional operators. Okay. And I'm going to put our dear friend, the main method. Okay. So let's do Boolean, just a variable Boolean. Let's call it A, and let's give it a value of true. Okay. Let's have another Boolean, and let's call it B, and let's give it the value of false. Sorry, false. Okay. Let's have another Boolean C, and let's give it a value of true. Let's have a Boolean, and let's just say D equals A and N B. Okay? And let's say Boolean E equals A, B. Okay? So now let's just print this and say V equals D, and then E equals E. Guys, what do you think we're going to get here? What do you think? All right, let me explain to you. This is the AND operator in Java, and this is the OR operator in Java. Okay, when we have the AND operator, both need to be true for the entire operation to be true. Okay? So if that is true, what do you think that this returns?
Is it false?
Correct. It will return false, right?
Yes, false.
Because both need to be true for that to be true. When one is false, completely false. Okay? Now, this one is a little different. This one, only one needs to be true for the entire operation to be true. Okay? So what do you think about this one? What do you think it returns?
True.
True.
Correct. Right? So let's print it. Or actually, I am printing the wrong one. I have to print this one. So take a look here, the right hand side, and we say D is false and E is true. Okay? So now, let me just put some sys out here. And another sys out. So we can see better when we print it. It's a little down here. Okay? Good. So now let me have another one. Okay? So we have sys out, another space here. And say int f equals 4. And we say Boolean G equals false. And then we say f plus less than 4. So guys, what do we get here? What do you think is going to be the outcome of this? What do you think G is going to be?
False.
Why is it false?
Because you have
False
one
because,
false.
okay, go ahead. Sorry, go ahead.
No, I think that you have one false, and it's make the whole sentence false. You need both true to be true.
What is the value of F then?
5.
5. No.
At the end, before it's 4 before the operation. The equal less.
No, it's gonna be true.
Guys.
False and false equals true.
No, false and false is false.
No.
Yeah, maybe the next.
Well, of course, false and false. If you have a false and you add a false, it's true.
Maybe the next programming language. Okay.
Donald Trump.
Wait, what is the value of F here? What is the value?
5.
Okay. 5.
5.
5.
And the value of F here.
4.
And the value of F here.
5.
I'm gonna say like Trump. Wrong. Right. Guys, remember that Java is read from left to right. As soon as it gets here, this part is not executed ever. It becomes false.
Oh, right.
It's a little tricky. Once it gets here, this second part is never executed because it became false already. Got it? This is called, in Java, this is called short circuiting. Short circuiting. It means that as soon as you see this false and it's an AND, if it is an OR, then you have to analyze both. If it is an AND, as soon as this one becomes false, this one is never executed. So be careful, that's tricky. Okay, so we can say here that this guy,
say that again.
This guy is never executed. Why? Because that became false since the very moment that says false here.
Oh, okay, I see.
So this, whatever it comes after, we're not even looked up. I mean, it doesn't exist. It became false rapidly. Right? That's short circuiting. Okay? Be careful with that, guys. If it is an OR, again, I repeat. If it is an OR, yes, both are executed. Because remember, the one needs to be true for the entire thing to be true. So this one is false. Okay, not a problem. I would check this one. Okay? But what happens if we do this? This one is not ever executed either, because you only need one to be true for the entire thing to be true. So as soon as it comes here, it doesn't even analyze this because it's true already. You understand it, guys?
Yes.
Yes.
With AND, both need to be true for that to be true. One is false, it becomes false automatically. Okay? Now, if I have and I have this, yes, this one will be executed because we still have to analyze the entire thing to see if it is true. But with this guy, it becomes false automatically. This is not even, this is ignored completely. This part here is ignored. It's never executed. All right, so we can have this one as well, Boolean. And then we have F minus, sorry, equals 4. Comparison, we're not assigning anything, we're comparing, okay? And then we say this G. So what do you think it's going to return?
True.
Makes sense, right? Why? Remember that it's first use and then decrement, right? So 4 equals 4, right? So that's true. But when you come here, G have become false already. So the opposite of G is true. Remember that this guy is the opposite, right? So if we have true, then it becomes false, right? And G, remember that G is false. We said that already. It becomes false. So this guy will return true. Guys, do you see it?
Yes.
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 But now, if we use F again, what is the value of F?
3.
3.
3.
We're going to use it here. It's 4, but then we use and decrement. Then the next time that you see F is going to be 3. Okay? So let's print it. Let's say this out. And we say F equals F. This out. G equals G. This out. H equals H. Let's print it. All right? Let's see what we get. There you go. So we got F because F is used here as 4. So this becomes true, right? And then F is 3. So it's used as 4 and decremented becomes 3. Okay? So this is the result here. Good. Let's have some more. So we say int, my int equals 3, right? And then we say int, another int equals 4. And then we say Boolean, my Boolean equals my int less than or equal to 3, right? And then and another int minus minus equals 4. And then we say, or my int plus plus equals 4. So what do we get here?
True.
True.
True? Okay. So let's print. Okay, sorry. Okay. So now we say let's print this out. So this is out. My int equals my int. And so this is out. Another int equals another int. And this is out. My Boolean equals my Boolean. Okay. So let's see it. In the first round, my int, this 3, it becomes what? What is this?
It will be 3.
Yes. True, right?
Less than
True.
equal. True.
3 equals 3. right?
Mhm.
3 equals 3.
Oh, I thought you were gonna write it in.
And then we have another int, right? Minus equals 4,
Which is
right?
also true.
It's the same as 4 equals 4, right?
Right.
Yes.
And then another int becomes what?
4.
No.
5. 5 equals 4.
Guys, 3.
No, 3.
Becomes 3.
It was 4 here. And then you decrement it.
Ah, yeah.
So it's 3. Yeah, so 3 is not equal to 4.
So now we see that my int is 3, another int is 3, and then it's true.
True.
Remember, this was 4 the first time you use it, but then you decrement it and it becomes 3.
Right.
Remember, you use and decrement, right?
Mm-hmm.
So now let's have another one. Okay, so this one we print 3. For you guys to remember, 3 and true, right? Perfect. Let's have another one. Boolean x equals true. In Java, you can do this. C equals true, and it's valid. Okay, you only put the type once, and then you separate the variables by comma. This is not valid. Okay, what is valid is this. That is valid, which is the same as this, right? But in the same line. Okay, now separate by comma, we just put the name of the variable and it works. Okay, it's like this. Is number 1 equals 2 and number 2 equals 4. Same thing, right? It's using this int for both, for this one and this one. Okay, so if in the exam you see something like this, that is incorrect. Here is easy to see because you see this red line here is telling you there's something wrong. But in the exam, you would not see that. Okay, so you have to remember that when you say int and int, there has to be a semicolon that finalizes the first line. If they are in the same line, this is the ideal way, right? But if they're in the same line, there has to be that. Or use a comma and remove the type in the second assignment. Okay? Good. So now we have int y equals 20. And we say x equals y, this, and then we have this guy, and then we have this guy, and we say is out x right, y c. Oh. All right. So guys, what's happening here? This is the bitwise operator. Okay. For these guys to be true, both need to be different. They need to be false and true for these guys to be true. Right? This is different from or and and. Okay? This is the bitwise operator. Whenever you see this guy, for the entire thing to be, for the entire expression to be true, one has to be true and one has to be false. All right? Don't forget this type. Okay? Of course, this one will be true because this one is true. Okay, y is 20, so y is not the same as 10. Remember that this is equals and this is not equal. Okay, don't forget that. When you have this guy before something, it will make that something the opposite. So if we have, again, we have this, it becomes false. If we have this, it becomes true. If we have this, it becomes not equal. Okay, it's y not equal to 10.
Yes.
Yeah, that's true.
So
True.
the entire expression becomes true because this one is true and this one is false. Remember, this is assignment. This is not comparison. We are assigning false to Z, right? Z was true originally, but we are reassigning a value and we're giving it a new value and it's false. Okay, so this C equals false. What it does is it sets Z to false. It was true originally, but now it's false. Now, if we
write down what the uppercase, the subscript, that little symbol, what that means in the comments. Yeah, the symbol. Mm-hmm.
What symbol?
Where it's flashing.
Oh, because the cursor is there.
Yeah. No. I'm asking you to comment what that means, so we have it in the documents.
Right, right, makes sense. This is, guys, if you take a look at the this is that I gave you before, this precedence operator that I gave you before. We have here that, let me see if I can bring this up. We have here this guy's right here. This is the bitwise exclusive OR. Okay, is the bitwise exclusive OR. They need to be false and true for the expression to be true. All right, so take a look at that table. I put it on Slack, right? And I would say that this is the bitwise exclusive OR, which means that for the entire expression to be true, both sides, okay, one side has to be true and the other one false.
Hi. The largest.
If R different,
Liquidated after the war.
he bring true.
Okay.
And
If they're different, they're true. If they're false, it is false. If it is true, it is false. They have to be false and true for that to be true. Okay, so let me print this. Let me print it.
You may not have seen the war, but I know the look a man gets when he likes killing.
You see that X is true? Because one is false and the other one is true. All right, so let me show you something here. Let me show you this guy. One moment. This guy here.
Give me your gun.
All right. So this is AND. This is AND. This is OR, and this is the bitwise exclusive OR.
Vampires don't move like
so, if X is true and Y is true, then it's true. That's with AND. Okay, can you please mute the phone?
You need to anticipate their trajectory to get a kill shot. Okay. You teach me to shoot.
Okay, so this is AND, right? Sorry. All right, this is AND. One moment. AND. Now, this is AND, right? So if X is true and Y is true, then it's true. Both are true, then it's true. If X is true and Y is false, then it becomes false. With AND, if one is false, the entire expression becomes false. If X is false and Y is true, it is false. If X is false and y is false, it becomes false. Okay? So for that expression to be true, both need to be true. That's with and. With or, if x is true and y is true, it becomes true. If x is true and y is false, it becomes true. Remember, only one needs to be true for the entire expression to be true. If x is false and y is true, then it becomes true. And if x is false and y is false, it becomes false. Now look at this guy. This is the guy this is the outlier, the different one, the one that doesn't fit in here, the one that apparently doesn't make sense. Okay? If x is true and y is true, it becomes false. Look at that. When they're the same, it is false. If x is true and y is false, then it becomes true, because both they need to be different for that to be true. If x is false and y is true, it becomes true. But if x is false and y is false, it becomes false. Do you guys understand this?
Yes.
Okay. So when you have and, one needs to be true, both need to be true for the entire expression to be true. When you have or, at least one needs to be true for the entire expression to be true. And when you have the exclusive or operator, as long as they are different, false and true, or true and false, it is always true. Okay? They need to be different. If it is false and false, it's false. If it is true and true, it's false. Okay? Let me paste this on Slack. Okay? Okay. Do you guys understand this concept?
Can you explain again? A little confusing.
With and, all the two of them need to be true for the expression to be true. If your name is Anand and you study in Miami-Dade College, then it's true, because your name is Anand, and you study Miami-Dade College, right? So both need to be true for the entire expression to be true. When one is false, it becomes false, right?
Okay.
With or, if your name is Anand or you study at Miami-Dade College, then it's true. So one needs to be true for that to be true. So I can say, if your name is Anand or you were born in China, it's still true because your name is Anand, right?
Right.
So ones need to be true for the entire operation to be true. With the exclusive or, the bitwise exclusive or, both, they need to be different. They cannot be both true or both false. They need to be false and true, or true and false for that to be true. Do you get it?
Yeah.
You take a look at this and compare like this. And then you get this. You compare this one with this one, you get this. This one, this one, you get this. This one with this one, you get this. This one, this one, you get this. Same here. Get this, like that. Like this, like that. And then you get these values here. It's a little confusing at first, but once you get, the idea of it, it becomes a piece of cake. And it's just like plain English. In English, it's the same. If you think about it, it's the same. Do you understand a little better, Anand?
Yeah.
Okay.
Got it.
All right. Let us see another one. Let's continue with another operator. Let's talk about the equality operator. Equality operator. Okay. The equality operators, because we have more than one. Okay. So PSVM, and then we have this. All right, let's say int A equals 5 and int B equals 3. Now, Boolean C equals A equals B. So what do you think that we're gonna get there? What is gonna be the value of C?
False.
False? Guys, do you agree?
Yeah.
And how about D?
True.
Okay, A equals B. Do you think that 5 equals 3?
No.
So that becomes false,
False.
right? So we say this is false. Do you think that A is different from B?
Yes. So D is true.
So that's true. Remember that this is not equal or different from. Okay? It's the same thing. This is equal and this is not equal. Okay? So now let us print everything to confirm. So we say A equals, and then we say A. So now we have this. And I say B, C, and D. Okay? And now I'm gonna leave a space here so we can see better. All right, let me print it to confirm. And then we see that A is 5, B is 3, C is false, and D is true. Okay, so I can say here that this means not equal. Okay, this guy here. Okay. Now, these guys is not correct because we cannot compare Boolean with an integer. We compare integer with integer, but not Boolean with integer. So this does not compile. Okay. Now we have another one. We have Boolean H equals false equals test. What do you think about that?
True.
No, that doesn't compile because we're comparing a Boolean with a string.
Right.
That doesn't compile. Okay, so cannot compare Boolean with int. Okay, this does not compile either, right? Cannot compare Boolean with string. Okay, you compare string with string, and you compare integer with integer, but not string with integer or Boolean with integer, things like that. Okay, let me have another one. Boolean x equals true, right? And then Boolean y equals false. And then we say Boolean c equals y equals true. And then we say and x equals false. And then I say C's out, this out and say x equals x. Y equals y. And C equals C. So guys, what are we gonna have here?
All true. I mean, true, false, true.
Let's see it.
I wasn't close.
You told me true, false, true, right? It is false, true, false.
Yeah, I was.
Because this is true, right? But then you reassign the value here. And you reassign the values here. So
I just didn't.
X will become false.
I just.
Y will become true. And true and false is false.
It's false.
Remember, and both need to be true for the entire expression to be true. One is false, automatically Z becomes false. It's a little tricky, you know, but you got to read carefully.
Yeah, I did notice that under Z, Y is first. So I looked at the value of X, which is true. And that's when it.
But you cannot confuse that with this.
But won't it take first compilation of the X is equal to true? It should calculate from top, right?
Yeah.
Y takes the value from the bottom.
Okay, here, right?
Mm-hmm.
X is true, right?
Right.
And then Y becomes false, right?
Right.
Then in this expression, Y is true.
Yeah.
You reassign the value. It was false, now it's true. Then you have to continue evaluating because they both need to be true for the expression to be true. So here, X is reassigned a value. Before it was true. Now the new value for X is false. The entire expression becomes false, and X takes the value of false, and Y takes the value of true.
So ultimate result will come from the last compilation.
Say that again.
From the last compilation, the result will be determined.
Yes, for the last reassignment. Now, guys, what if I do this? Let me print it that way. Okay. Let me do this. We put here some C's out. And let me do here something here. So what do you think is going to happen if I do this?
False, true, and true.
Let's take a look at it. Okay, I have to use 1, 2, 1, 1, and 1 because I have the same values, okay? The same, I cannot have the same variables. Okay, so let's do it now. What do you think? Can you compare? What happened? Who can explain what happened?
So X1?
Before X was false, Y true, Z false. Now the three of them are true. Who can help? Explain to me what happened.
I will try.
Oh, okay. Well, X1 is true.
Only assign one of sorry, no sé si lo entendí. Solo escogió una de las dos asignaciones. Sorry.
I don't speak Spanish.
Sorry.
Try it. You'll be fine. Don't worry about it.
I am Cuban like
Try, if you don't try, you're not gonna get better. So keep trying.
Dieva,
Oh,
Dieva, I understand perfectly what you're saying. I'm Cuban like you, but I don't speak Spanish.
okay. In the first line,
What line? Number? What is the line number?
33. In the 33 line,
Okay. Yes.
the only sorry, I can I don't know how can I say this
I understand.
sense. Sorry.
I hope that what you're trying to say is the truth. The truth. Okay. I hope. Okay. Anyone else wants to help?
Yeah, I can try.
Try, please.
In 33 the value to y1 is assigned true. And in this parallels, if these two pipes, one is true, then the statement is true. So x1 is also become true.
Okay. Do we analyze this?
No.
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 So, as this becomes true, and for or only one of the two sides needs to be true for the entire expression to be true, this is not even analyzed. This is completely ignored. So this assignment will never take place, and x1 will continue to be true.
Exactly.
Okay? Here, as y is true, and both need to be true for that to be true, it has to analyze both sides because it's and, right? So this one is analyzed too, and then x becomes false, but the entire expression becomes false because only one member needs to be false for the entire expression to be false. Okay? Now, this case here, y is assigning a true value. Y was false before, but now y is true. And x is never assigned false because this is true. And when this is true, z1 becomes true. That's why you have x1z true, true, true. Do you guys understand the logic behind this?
Yeah.
Yeah, but why they made it so complicated? They can write simply.
I'm gonna give you the.
I agree with you, Anand.
Yeah, I'm gonna give you the email address of the Java creator. I'm gonna give you his personal address, mailing address. Send him a letter and ask him why you made our life so difficult. Why? But you know, the one that created the language is the mean person, but even meaner is the one that created the exam.
Wow.
Okay, so you know, Java is to be enjoyed. The exam is to cry. You know, it's, guys, I gotta be honest to you. The exam is created diabolically to confuse you. That's the main intention of the exam. I have never seen an exam before that is more intended to confuse you than the Java exam. I've never seen that before. Every single question in the exam has a little detail that will drag you to fail the question. It will pull you like a magnet. Come here, fail. It's incredible. It's incredible. That's why you have to be very careful, read carefully, analyze, and analyze fast, because you only have like a minute. It's like a minute and 30 or 40 seconds per question. So
how many questions there?
65, 70% pass.
65, and how many minutes?
It's 2 hours and 30 minutes.
No, that's not bad.
150 minutes.
150 minutes, I think, if I'm not mistaken. Let me see here.
You said how long? 2 hours and 30 minutes?
Yeah. Let me see.
That's 120. And, yeah, it's 150 minutes.
150 minutes. 70 questions, 65. 65% is the passing score, not 70%. It's 70 questions, 70 questions, and 65%.
65%, okay.
65%, 70 questions. So don't rush. When we finish the course, don't rush to take the exam. Continue studying. You know, you don't want to rush and then not have the desired outcome. So when we finish the course, continue implementing what we study. Continue studying. Give you one more month.
Okay, so there is a time, no problem.
You know, complement, supplement, get some other courses like Udemy, the shorter courses. You know, do a lot of Wiz labs, a lot of. I'm not sure if I don't think the Cloud Guru has that because this is not a cloud course. I don't think they have Oracle. You have to try with Cloud Guru. Maybe
Coursera has.
Yeah. Okay. What do you say?
Coursera.
Coursera. Okay. Good. Okay. So now let's see another class here. Let's talk about object equality. Okay. Object equality. Okay. Remember that an object is an instance of a class. Don't forget that. Okay. This is an object. Okay. Name is an object of the class string. Okay. So if I do name, actually name, I don't get anything because name doesn't have a value. I'm gonna say Dunieski. And the name. Okay. But you know the class is string is a class, so name is an object. Okay. Let's create some comparison of objects. So we're gonna compare objects now. Okay. We compare numbers, right? Doubles, floats. Now let's compare objects. Okay. So integer. Remember this guy? What is it called? What is this guy called? The integer class. What is it called? It sounds like a music singer. The rapper. Don't forget that. A rapper class. Okay. We have one integer there. It's 127. And they have another one. And this my another integer. Okay. And now we just say 127. Okay. So let's do this. Let's just compare these two guys. Okay. Says this out. Oh my God. I know why I forgot to put this guy. Okay. That's why we were getting some issues there. That's why when I put this guy here, name, I was not getting anything here. Like the bunch of methods that the class string has. Okay. Good. So we're comparing objects. Now let's do some print here. Let's compare the two objects. Okay. So now say my integer equals my another integer. What do you think that that's going to return?
$127.
We're not assigning, we're comparing.
Be true.
True? Let's see.
Let's try this out. Yeah, that should be true.
True. Okay? They're true. Why do we do this? What do we get now?
127.
True.
Oh,
True.
We're comparing.
I still compare.
Yes.
Okay? We're comparing. So we get 27 here. This becomes true, right? And this one becomes true, right? You can compare with this equal symbol and equals, okay? This one will compare the address in memory, and this one will compare the content, okay? But we're gonna see more now in other exercises. Okay, so now we have another one. We put space here, and we say sysout 128 equals 128. Just give me 1 second, please. $128, and then we say this is this guy here, say, and then we say okay. So what do we get here? Let's say
True.
true. The two numbers are the same, right? Now let's say something. Sysout. Okay. And we're gonna say now my integer hash system dot identity hash code, and they'll say my integer. Now we're gonna say sysout my another integer, right? And let's say system dot identity, and then my another integer. Let's see what happens here. So we're gonna do different numbers here, or the same number.
Same number.
Same.
Okay, because they have the same address in memory. This returns the address in memory, the hash number. So let me put here the hash. Okay. The hash is a code that objects return with the space in memory. Okay. So that will return the same numbers. Okay. If we have another number, let's say that we have here 29. That's not here. That's 28 here. Maybe 29 here. And then we say here. You see how it changed? You see how the number changed?
Yep.
Oh, yeah.
That particular number has a different address in memory. So now we do this, and it returns an integer. You see? Now if we do 127, and we get exactly the same name, same number. Now, if we do this and reassign the values, and we say my integer equals 128, and my another integer equals 128, right? And we do exactly the same. Take a look at that. and we get different numbers. Because when the number is greater than 127, then the address has changed. If you take a look at here now, it's 1913 21 50 14 26 66 8 47. Okay, if that it is greater than 127, then the numbers become different. I don't know, you guys, if you see it before the word 27, right? Let me see here if I can have 128 26. Let's see what we get. You see, they have the same number. If we do the same, and we have, let me put a sys in the, not sys out in the middle, right? Sys in the middle, so you can see the difference, right? See the difference now? You see? Here, we have 127. 127 here. Then we have 128. And then we have 127, 26. What if we have 125? We have the same address, you see? What if we have, let's say that we have 129, okay? 129.
We're different.
Look at this. Do you guys see it? Whenever the objects are greater than 127, the address changes. Okay? Less than 127, they have the same address in memory. Okay?
What happens if they are negative?
If they're negative.
Yep.
You see? What happens if they have 128? You see, guys? Do you realize what's going on here? Do you guys realize what's going on here? Remember the byte?
Mm-hmm.
Remember the range of the byte?
Yes.
Minus
Yes.
128 to 127?
An integer
Is
is 32 bits.
If the values
Jeez, 4 bytes.
of an integer object range from minus 128 to 127, they have the same hash code and the same memory address. So the integer that is returned is the same for both numbers. Do you guys see it? Okay.
Yep.
So that's a very tricky thing in Java. Okay. Now, if we compare 128, let us do this. We compare 128 with 128, my integer equals my another integer, what do you think we're gonna get? What do we get here?
True.
Are you sure? Remember that when it's 21, 28,
False.
they have different hash code. So if we take a look at this, it returns false. Remember that when it is greater than 127 or smaller than minus 128, they have different hash code, and therefore they have different location in memory.
Right.
Okay, so this returns false. Now, what if I do this? This is how my integer equals my another integer. What do you think it's going to return?
True.
True. Why? Because the equal equals, it checks the memory location. The equal symbol, the equals method checks the value
The
of the
values.
variable. The value is 128 and 128. So this is the same as this. This returns true. True or false? This returns true. Don't forget that, very important for the exam, the equals will check location in memory.
Can you make the note there,
Why not?
please?
Equals checks location in memory. Whereas the equals method checks the value. Or maybe not checks, compares. Okay? Compares location in memory. You want to see how interesting this is? Let me compare 26 and 26. What do we get now?
True and true.
True.
Let's see it. True and true. Remember that between minus 28, 128, and 127, they have the same hash code. Therefore, they have the same location in memory. That's why 126 and 126 equals returns true, right? So this, I'm going to put this true, and this one returns true. Guys, do you see the difference here? Do you see it?
Yes.
Yes.
Good. Let's do another one. Don't forget that this, my integer, equals 125 is the same as integer value of 125. Don't forget it's the same, okay? So whenever you see this guy like this, and I think that we saw it the first day, the very first day of class, this is one way to put it, okay? So these are the same, okay? So this is the same as below. This is the same as above, as line 56, as line 57. Okay, good. So let's see another example. Let's say integer int1 equals new integer. And of course, guys, this is not necessary, but this is for the sake of practicing. This is unnecessary. Unnecessary boxing new integer 1. We can simply say 1. Okay? But for the sake of practicing, let's do this way because we are creating an object of that class. Okay? even though this is an object too. This is an object, okay? Remember that integer is a class, and whatever you create here is an object, okay? And this is another way to create an object, just with the keyword new, right? Let's create another one, integer 2, and let's say new integer, and then 1, same thing. And let's say integer int3 equals 1. Okay? Now, see how interesting this is. Okay. Now we have compare first integer 1 equals integer 2, right? And then we say equals, right? We say integer 1 equals integer 2. Okay? Now we do the same thing with integer 1 and 3. 1 and 3. And 2 and 3. Beautiful. We can print this.
Change the second one at the end.
Which one?
It's the second one. It's int 1.
Yes.
Yeah, right there.
Thank you. So let's just print it. False, false, false. Okay? It doesn't matter if they have the same value. Remember that this guys checks what? What does the equals check?
Memory.
The location in memory, right?
Mm-hmm.
These guys are two different objects. They're two different objects, right? Even though they have the same value, they're two different objects. They have different locations in memory. Okay? And this one, is another object. Even though they have the same value, they don't have the same location in memory. That's why it says false. But what if I do this? What do you think is going to happen? Let's see. True, right? True. So let's do it this way for you guys to understand it better. 1 equals into equals, and then this, and then we do this. Okay? So now you see it better? It says int equals 2 equals true. Because what does the equals method do? What does the
compare values?
It compared the values, right? Mm-hmm. And the values 1 and the values 1. So let's do the same here, right? And instead of 2, it's going to be 2 and 3. And then, I'm sorry, 1 and 3. And let's do the same here. And let's do 2 and 3. 2 and 3. So we get true, true, and true. You see there? True, true, and true. Why? Because they have the same value. 1, 1, and 1. Now, if I put 2 here, then we're going to get a false down here. Right? We're going to get a false down here because it's not 1 anymore. Okay? Guys, you have to understand this, the difference between the equals and the equals method. Okay? One checks the memory location and the other one checks the value, the content of the object. Okay? Maybe I should do this. Maybe I should do this, okay? I should put it separately, right? So you can see it better. Okay, let's put it here. Much better this way, right? It's much better this way. Do you guys see it?
Yes.
Yeah,
Okay,
that's perfect. Yes.
so let's do something else. Let's just check now the hash code. And guys, someone wants to, who is doing this at the same time I'm doing it? Who's following me in their computers? Is anyone following me or just watching me?
Just one.
Okay. Okay, who wants to just have control of my computer and check the hash code, the identity hash code of these numbers? Exactly the same. The hash code for int1, the hash code for h2, 3. Who wants to ask me for just control my screen? Who wants to do it?
What we need to do?
Just find the hash like we did before, like here, similar, but with these 3 numbers. Just here. Who wants to do it? You can ask for the control for me, okay? Or I can give control to whoever wants to do it. Maria, you want to do it? Mary, you want to do it? I can give you control. Maria? Maria's muted now.
It looks like it's me, right? What are we comparing? The hashtag of what?
The identity hash code. Remember we did it here?
Yeah, but we're comparing it between the
We're just printing the hash
variables.
Code. We're just printing the hash code of int1, the hash code of int2, and the hash code of int3.
Just print them out?
That's it. No more than that.
Okay, go ahead.
You want to do it?
I'll try it.
Okay, no problem. I give you control. There you go. You have control now. You're gonna paste it?
Of
You're gonna copy and paste it?
That's smart.
Wow. Wow. What if my code doesn't exist? What are you gonna do?
Then I have to type it, but now it exists, right?
Okay, that's a smart move. No problem.
Okay, so now we're talking int.
It's your computer.
int1.
That's not the name of the variable.
Lowercase I.
Oh, thank you.
It won't give you an error, but it's not accurate.
It's just, that's a comment, right? Okay, so here.
No, it's not a comment, it's a string.
It's a string, yes. So here, what's the name of this one? I need to delete this. And one. Come on, paste.
Hit enter. Hit enter.
Oh. Okay, now
It's not gonna copy the S. It's gonna copy them. It doesn't matter, just put the S at the beginning.
it's slow when you're doing this.
Forgot the S in the system. First word. Okay, the first word. System. First word of the line.
Mm-hmm.
At the very beginning of the line.
First word of the line.
No, far left.
Okay, yeah.
Oh, yeah.
The very first word of the line.
In the beginning of the line.
You're in the middle. No, that's fine.
System that out. System that out.
Go to the big, yeah.
Oh.
Yeah.
There you go.
Right.
That one, right?
Yes.
Yeah.
Awesome. Thank you. And then the next one is.
You will have to do the same. Okay.
Come on, paste. And then this will be 3, right?
Yeah.
And here 3. And
right. You run it.
There you go. Wow, 3 different memory locations.
Yeah, because there's 3 different objects.
Mm.
Okay. Remember that when you create object like this, they're different. If this is giving you false, remember this guy here. Where is it? This guy, they give you false. It means because the 3 of them they have a different hash code. All right. Thank you, Maria.
Oh, you're welcome.
Okay. Now,
Maria, awesome. Good job.
Thank you, Maria. Thank you.
Thank you.
Okay. So now if I have this, what do you think we're going to have? Let's see it. Oh, I forgot the semicolon. Okay. Why? Why int 3 and int 4 have the same hash number? Little quiz for you guys.
Because you didn't create a new object with the new integer?
Correct. But remember that when you create an object this way, right?
Mm-hmm.
If it goes from -128 to 127, they have the same hash code.
Mm-hmm.
Remember we saw here? If the values of the integer object range from -128 to 127, they have the same hash code and the same address member. So the integer that is returned is the same for both numbers. Okay.
I think I was sleeping when you were. Can you go down? down?
Wait,
up.
This will create
this here. What? How did you create this? Because I don't remember you doing this.
I did it just now when you finished.
No, the top one. It says new and then
here
a line over enter. No, down. Right there. Int 1. Right? How did you create that integer with a cross out?
No, that's a warning that Java
warning. Okay.
Give you. IntelliJ gives you that warning because it's unnecessary. It's unnecessary. Okay, but this guy will create an object that is completely different. This one, this new thing here, it will create a different object. Okay.
So what is new?
New is the key word to create an object. Remember, we create an object here in the test person. Remember? That's the way you create an object.
Oh, a new object, no?
Because when you do this, person free, you just create a reference in memory. You don't create an object, right? So you have to do this to be able to create an object.
But do you have to write new every time, or you can write anything else?
Well, this is a custom class that I created, right? That's a custom class. The integer class is a class that is built in Java, right? with that class, let me see, where's that? With that class integer, I don't need to use new. The same with string. Right? String is a class. String is a class. This is unnecessary. It's going to give me a warning. Okay? Like that's not necessary. Okay?
So what is it creating on the first two? New?
It's creating an
value
object.
Of 1.
It's creating an object. Yeah. The value of 1 is the number
It's
1.
creating a,
You're assigning number 1 to int 1. If you print int 1, it's going to return 1. Okay? But that's unnecessary because you can do it this way. Right?
But it's a completely different value. So
right.
What will be the validity of doing that?
No, they have the same value, but they don't have the same memory location.
Oh, yes, exactly. So they have the same value, not the same memory location. What will be the value of that?
The value of this one? 1.
No. What will be?
Oh,
why would you want to do that?
Oh, you don't want to do it.
My question.
You don't want to do it because this is not a matter of memory location. This is a matter of working with values. You don't need to do that.
The programming language allows you to do it, but it's not necessarily something that you want to do in real.
Correct. If what matters to you is the value only, you can do this. The memory location doesn't matter.
Mm-hmm.
Okay? But if you do this, you're creating a new memory location. Whenever you create with the new word,
I guess it will be useful if you're saving, regardless of the value, if you want a new memory location for what you're doing.
To be honest, I wouldn't do this.
But I wouldn't do it that way because it's an integer. So
I would do this way because Java right now can accept this, right? It can accept this. This one is necessary. This is redundant. It's like this one. If you hover over it, it tells you new string is redundant. You don't need to do that. You can do this, right? And that's it.
Yeah.
It's just for the sake of training, because I don't know, man, they have a diabolic mind. They're trying to destroy you in the exam. So they can do things like this to confuse you. And don't quote me, please. Don't quote me. But I don't think that is intended for you to pass that easily. Okay? I've taken a lot of exams and never seen an exam that is more towards destroying someone's self-esteem than this one. But it's doable. It's doable. It's not impossible. It's just that it's intended to do that. So that's why you have to be very prepared for the exam. If you're prepared for the exam, it doesn't matter. You just need to be cautious and careful, and read carefully. And do not change the answer once you have answered. Because if you don't know, you don't know. Okay? So if you answer, when you go back to check, don't change the answers at last minute because it's being proven, scientifically proven, that when you do that, you most likely get it wrong. Okay? Many people have failed exams because they changed the answer at the last minute. They had it right, and they did it wrong, and they changed the value. Okay, guys? I think that we have learned a lot today, right? Yes.
Yes, sir.
It's 8:24. It's almost time to go. We cover a lot today. We cover assignment operators. We cover compound assignment operators. We cover relational operators, conditional operators, equality operators, and object equality. Okay? So we're going to continue, with module 3, right? Module 3 on Tuesday. We're going to cover if-else statements, ternary operators, switch statements, while loops, do while loops, for loops. So this is becoming more serious. Okay? Guys, don't be discouraged. Just be prepared, study, you know. You're not the only person that's taking this exam. You're not the only person that's going to pass it. Many people have passed it before you guys. It's not impossible. It's doable. Okay? You just need to be prepared for that. It's like for anything in life. For an interview, you have to be prepared so that they don't catch you off guard. Okay? Same thing in life. Okay? So I'm going to, right now, I'm going to push this guy. Okay? I'm going to move to the Java, this guy. I'm going to add it. I'm going to commit it. I'm going to say that today we see the assignment operators. We saw the compound assignment operators. We saw the relational operators. We saw the conditional operators. We saw the quality operators. And we saw the object equality. Okay. So that's has been committed, and then I get push, and it's pushed to the repository. So now if you check your Slack, you're gonna see that a new commit has been added to Slack. Okay. And then if you check GitHub, we're gonna see that GitHub has been updated. No, not that one. This one. As you can see here, there's more information here, and then there's much more the things that we saw for today. Okay. Have all the code here that you guys need for that particular topic in class. Okay. Any questions, guys? Do you know that you can fork this? You can fork it.
Yep.
You can fork it to your repository. So far, Appin Miami, David Gonzalez, Maria Pena, and on Mara Montoya, they have forked it. Okay. So maybe you want to.
Appin Miami is me.
That's you. Nice. So maybe you want to fork it and just review it from your account, and just probably clone it to your computer, and just reproduce it in your computer. Change the values. Just take a look at it, you know,